All right, now we're live. All right, we're back with Michael. How was work?
Howdy.
So
Boring, slow.
I, I yeah, I go to work. I switch to days tomorrow, and I go to work for the next 4 days or 5 days, I think. So I won't be able to get back on
Okay,
for
a little bit.
yeah until Wednesday at least.
All right,
I mean,
yeah, and then
I can
that
still message,
that
but
coincides with my schedule, kind of. I mean, I have off Sundays and Mondays, but it's better honestly when I'm working, just because it's so slow. I can kind of
right,
do this
yeah.
at work for the most part. Um, yeah, what was I gonna say? Oh, the one thing I did want to do
Um,
is, and I'm not even talking about the sun. Uh, but I would like to set up a thing to see if we can just put a light up and measure how far away that light is.
I was gonna do that too. Like, um,
Yeah.
there's a there's a instrument you can use too to measure the intensity of it. I can't remember what it's called, um, but like you can see like from where I work, we're at 2,300 feet elevation.
Mhm.
Give or take if we're up or down. Uh, but I can see all the lights from the city. You know, and
Yeah.
like the lights on the radio towers and stuff like that. The blinking red lights for the planes.
Hmm.
And you can see those, but those are what 10 inch. I don't know what they are, 10 inch bulbs or something, and it's straight line distance isn't as far as it's not that far, but you can definitely see
Yeah.
it, right?
So more what I'm speaking is like just me myself. If I just take a light and I'm just gonna assume, whatever, it's flat. One guy I saw on one of our conversations, he posted like the picture, the error Tosthenes or whatever, and it's a flat table. So okay, but we can measure that where the light is. We can say, okay, the light is this far away because of how the angles are. So I would like to do that to see if we can. If I
Yeah,
put a light, whatever, 3 feet up, and I measure it out, and that's what I get with the angles, well, then we can assume the same thing would work in reality, right?
right. Yeah, I know what you're saying. Yeah. So
So
if you measure
that's what
the
I mean. So we can measure the actual sun.
yeah, you
After
could
that, we'll do something small first.
right. You could do those small scale measurements, and then you could try to determine like the height of the sun. No, or
Yeah,
not the
it would
sun, but
have
your
to
light,
be
your
a
flashlight.
that'd be a lot harder because it would have to be, I'm pretty sure it would have to be a significant distance if in order to do it correctly, and it also has to be on the same longitude lines.
Yeah. So somebody in the project analyst page posted a picture of that, right?
Yeah, it was like it
Right.
was like a cartoon or whatever,
Yeah, a cartoon, but it was
and
it's what you're talking
I
about though, right?
I think so, yeah. And actually, you know what he posted the picture of it had like a cartoon of Eratosthenes, but the
Right, yeah.
actual picture might have been real because it was like batteries or something that were being used.
Right. Let's
So if
see
I knew
here.
how tall those were, we could measure the length of the shadows and then determine how far away that light was. But
Right. But
obviously, I can't know that, so I have to do my own.
yeah, we can't determine that off of their picture, of course. And
Yes, yeah,
that's something that is it's always going to be it's just a talking point because, you know, you can't measure the distance to a picture unless you know
no.
what
Well,
the
if I
screen
knew
is,
the size
unless you know
of
what's
those
around it.
things were, yeah, absolutely. I'd have to know the size of the thing standing,
Right.
and then I could, if you knew the size of the thing standing, you could then measure the shadow based on the size of the thing standing.
Right. So this
And
picture
then,
here,
yeah,
right, has okay, this would be the observer, the observer's point of view, and then the horizons out there. Of course, they just pasted a tape measure on there, but you know, I don't know where this is. You know, I don't know where this is. I don't know where the guy is standing from to take this picture. You know, I don't know.
Yeah,
His
it's not the one I'm
elevation
talking about though.
No, I know. I'm just saying if you were to look at a picture and be like, where's the, like if I was to say in this picture here, not the globe, but just a picture of the water.
Yeah, there's no way of
sun,
saying how high you are. No, absolutely.
right? I would ask you how far away. You know, where's the 3 miles at? And you can't
Go
tell.
on
But
the page. Go to the link that I sent with the flat Earth, like the guy math, like the guy that uses math or whatever. And then under those comments is where he put the picture I'm talking about.
no, that
A
was
little farther up. A little farther up.
no, that wasn't this one though, wasn't it?
Hold on, no, a little more. A little more up. That one. The comments in there. And on that one, math was yeah. Like if you click on the comments, it should pop up. Down at the bottom.
Yeah, this right
That.
here.
Yep. So yeah, so I was like that's a cartoon,
Yeah,
obviously
so
down at the bottom left.
this is soda cans or some kind of, and
Yeah,
but
I
I
know
can't
what
even
those
tell
were.
what kind of can it is though. But they're
I
all the
know
same
that's
size can, and that's a picture, and then of course that's a cartoon. But yeah, so the light would be
we can't
directly
see the
above.
light.
Well, yeah,
Well, not
no,
even
not
because
that.
it's if it was directly above, there wouldn't be a shadow on the one on the end, even though it's smaller though. But if we did
Yeah,
know the
so
size of the cans, we could
the
measure
light.
each of those shadows and determine the light.
Yeah, I'm over here pointing at the thing on my screen, and you're not seeing where I'm pointing on this live
I
frame.
know my phone's
Yeah,
too small.
yeah. So the light, wherever the light source is, the light source is going to be over here somewhere. You know, over more.
Where's your? I can't even see your cursor.
Oh, you can't.
No.
To the left of the picture.
Yeah, to the left, top left, top left. Yeah, yeah, absolutely.
Yeah, it'll
Because
be
that's
somewhere.
where
Yeah, right. Yeah,
and the shadows are running,
right.
straight
And
across the middle of the table.
all these cans are the same size, and then they show different shadows with the, and if they had a good better picture, it would be one with no shadow, and then the elongated
Yes.
shadow. So what you're saying is you can measure this shadow here
To determine how far away the light is.
right, knowing this
Size of the
light,
can.
and then this shadow, it would be some kind of equation because the shadow lengths are going to be different because shadows are not
Yep.
tangible.
Well, yeah, but that's because they're different shadows,
Yeah, that's why you have
and
to measure
because we
each
would
one.
also know the distance between them.
Now, if you
The distance between each can, because that was a big part of it.
right, yeah. So you have to know all that, yeah. Yeah, so
To get
that's
the
something
angle
that,
of change. But it's doable is all I'm saying. So if I could do it on a small scale and just say, okay, boom, the light's up here, test it, measure it 3 feet away. I get a tape measure. Oh, look, it's 3 feet away, just like the shadow suggested.
right. Yeah, no, I know what you're saying. And we could try to
theoretically
do that,
measure the light.
you know,
And we
right,
won't
with the sun.
we won't assume that it's round like he did, because that's the only reason why he got the curvature, because he assumed it was round, and then that each one standing up went all the way down to the like the radius,
Yeah,
like
and
sticking out.
it's funny too because the stories don't even match up. One story is it was the obelisk, and the other story
It's a well. I know.
It's two different stories, but
I know. I'm not sure if what's his name was just using that to give a good example. What's his name? Sagan. He was just using that to bend it or what? I don't know. I'd love the backstory on that too.
So you've seen that video with Carl Sagan where he's taking the map
on the paper,
he's bending it.
Yeah.
So something with that is light reflection. Something up. It's another topic. He took and bent that to get the shadow to demonstrate how the shadows would work, except he was bending a cylinder as opposed to bending a sphere, right? Because he just took this flat sheet and bent it in one direction, but the sphere bends in all directions. So it's not even an accurate demonstration of what would be seen anyway. But anyway,
true. I see what you're saying there.
Yeah, so there would be shadows in every direction. It would be like
well, no, but there's still only one light source.
No, I know. But what I'm saying is there would be shadows. If we had cans in a circle all the way around the center circle, and then we shine the light just above the center can, all the other circles would have a shadow in different directions. just in a circle.
No,
I'm saying,
because
like in this table,
so a sphere,
thing.
right? Well, because it's no, I know what I see what you're saying, but as long as they're straight, the things you're trying to measure are straight up and down. Because that was a key piece. That they're straight up and down. That
No, I know. Yeah, I know. I'm just saying. All I'm saying
because if
is
you
light.
cut a circle out of a cylinder and you cut a circle out of a sphere, it'll still be the same size circle. If they're the
Yeah,
cylinder has a certain
but
diameter and the sphere has a certain diameter, it'll still be the same.
right. If we take the center can on the screen, right,
Hmm.
and then well, the second one from the right, and then instead of putting them in a line, we put them in a circle around it, and
Yes,
then
yes,
shine the
yes.
light straight above the center one. All the lights, all the shadows are going to splay out. And all I was getting
Yeah.
at was it would do that on a sphere too, because
Yes.
but we're only measuring in one direction. That's why it's in line. So
Well, and I think this is also another thing that can be done too, because I know in Hawaii and of course along the different tropics in a certain time of year that there is no shadow, and it's kind of a creepy experience. If you're out in the daylight, there's no shadow. You don't have a shadow, like a can or something doesn't have a shadow. Obviously, if you put your
yeah,
hand out, you have a shadow because the sun is exactly directly overhead. And if you were to talk to somebody farther north or farther south, the shadows would be opposite.
yeah. The different things, you could play around with a lot of different experiments and do that. I got into an argument one time with a guy about shadows about and what it comes down to, it doesn't really necessarily come down to the shadows. Okay, it comes down to he assumed a parallel lights coming in at parallel from the sun, parallel sun rays.
Yeah, well, we can measure the parallel sun rays. We know they're coming in parallel.
Well, that's the thing. No, I've never seen observable parallel sun rays. Only crepuscular sun
Well, no,
rays.
okay. Well, see, if you're talking through the clouds, then that's a combination of two things. It's a combination of the atmosphere and it's also perspective. Just like you're saying, you can't know that the clouds in that picture are above or below Mount Rainier. You can't say like because you're looking at them from a different angle.
Well, we
So
can't know
one's
that from a
farther
picture.
away.
We can't know that from a picture. We
Exactly.
can
So
know that if we were there.
I'll agree. Yeah, but if you're looking at a picture and you're seeing rays come down one way and then farther away, it looks like they're coming down at a slightly different angle. That's because
Yeah,
one's farther away. It's
right.
the
And that's why
same.
I showed you that picture and the video of the auroras. It looks like they're going straight up
Yes.
and down, but they're not. So
They're not. I know, and I know
yeah,
they're not. It's because I know. I guess if I didn't
but
know, yeah, I would say, "Oh my gosh, it almost looks like it's coming from the ground," but it looks like it's going over. And if I were to chase it, keep going, it would never. I would never actually quite get too high up in the atmosphere.
right.
So one thing I did want to do was something that we would observe if it was flat. That everyone thinks we would is that we would see the sun at all times. So even if it's nighttime here and I got to a high enough elevation, I would still be able to
Yes.
see the sun.
So that's not that would be based on the globe mindset of the sun's light, and it travels infinitely far, 93 million miles. But that's so you have to take, if you're gonna take the flat Earth as just a flat Earth, you have to leave off the globe stuff, because in the flat Earth the sun is local, and it's a limited light throw, and I can see that here in Alaska. When the
Yeah.
sun rises, the light from the sun, not the daylight, that's two different things. But the light from the sun is it only throws so far. And those pictures that I showed you, the pictures of the
Yeah,
sun.
of a sunrise or a sunset.
Yeah, I can't remember what it was. I think it was sunrise. But anyway, you can see where the light from the sun stops, and it doesn't go any further. And so the sun on the local in a local flat Earth, local sun, it's a limited light throw. And there's even videos where you can see day and night, like you can see the sunlight and then it's dark, all in one photo. So it
I'm
doesn't.
trying to think.
The light of the sun doesn't travel as far as we think it does. So if
But that's an assumption.
no, that's what you can observe. That's what I'm saying. You can observe that
Well,
in the photos.
okay, so like when
Past
it's still daytime for me here, or when it's setting for me here, it's still kind of daytime for you in
depends.
Alaska.
It's dark. It was dark right now at 4:30. That's why.
Yeah,
That's why I came in.
yes. Your 4:30, my 4:30 is the same time, but it's different because you're like 4 or 5 hours ahead. So
Right,
what I'm
but
saying is
but
when it's because
4:30 at
right
night
now
doesn't get dark for
it's
you.
9 o'clock for me. That's when a sunset. Like official sunset is well now it has it on sunrise, but I'm pretty sure it's like 4:20 something because it keeps getting smaller until the 21st. So my point is though, I'm not able to see the sun while you can
Right.
see it at a certain point in Boston. But there is a time we can both see Polaris, which is we would agree smaller than the sun, but yet we can both still see
The
it.
light, yeah, right. The light is smaller, yeah.
But we can both still see it at the same time. We can both see Polaris, and that's something I also want to do
Yeah,
because I
yeah,
want to measure
yeah,
it.
we should be able to, yeah.
I want to measure Polaris in the sky, like the angle of it, like how far I have to look up compared to how far you would have to look up being so far north.
Yeah, so that one guy that does IR ones, he did some videos on measuring the distance to the stars too.
Okay, I gotta
I
check
mean,
that out. And I did
I
watch
have
his
a hard
video again.
I ain't gonna lie, I have a hard time with his voice. Like I watched probably
I
half of
know.
it.
I watched all of his video today. The whole while I was sitting after we got done talking, I watched the whole
Yeah.
thing. And I seen the
And
beginning where he's explaining his flight and where he's going. The only problem is I don't know where he's at, and he doesn't know where he's at when he's filming. And he also even said he doesn't know what mountaintops he's looking at. He doesn't
yeah,
know
but
which
then you
ones he's
could
looking at. So
but he goes into using the tool of like Google Earth. He goes into where you know where what you can see and what would be identical. But he has to anyway.
but he doesn't know
Like
where
I
he's
said,
at is my thing though, because he can't
he
do
has
that
a
on the
lot
plane
of
because he doesn't have service. I don't think. I don't know. Pretty sure it's
yeah.
all uploaded post.
I'm not sure what he's using, but you know, to tell like his altitude and all that stuff. But um, yeah, I mean, you have and that some of that you have to just take on face value or whatever. Like if you're in the plane and the seat says that you're flying, you know, in this
Yeah.
direction, you can't actually validate that unless you can actually see something out in the distance. You know.
Sorry, bit of a situation.
Oh, it's fine.
Just trying to get here back on another train. Always something going on here. Always something.
Right.
Anyway, yeah.
So
So
let's go. Let's go to just talking about the sun for a second.
okay, I
I'm
was
gonna
doing a
pull
little
these.
more research on like I'm gonna butcher the hell out of the word spectros measuring the sunlight and how they go about doing it and how they go about telling
Right.
what molecules and stuff are being sent.
Right. So the assumption of parallel sun rays coming in has never been shown in photo or video. You only see the crepuscular rays, whatever, however you say it. Right. So
Yeah, but
you
all these
can
pictures here are coming through clouds, which, as we know, reflects sunlight. I mean, we can't have it that the atmosphere will make the sun that's above us
well the clouds are
come below us under a cloud, and
like this one here. You get this one in the top left, right?
top left. Yes,
Now,
I see.
you can see that the clouds are dense, so dense that right,
Yeah, some of them.
it's not going to reflect or reflect or anything. It's just the sunlight passing through where it's not dense.
Yeah, and if the where it's not dense is like giving it a shoot. You
Yeah, so
know?
all these sun pictures, and this is all you'll ever see is these type of rays, crepuscular rays. You'll never see rays coming in parallel.
Yeah, and they're all pictures though from a distance, from different angles. So if you were to get up under those and measure the shadow in a straight line from each ray coming down, would give you the exact angle that the rays are coming in.
Yeah, yeah. So you're gonna have what I'm saying is you can't. You can say parallel, but you can't observe that.
Well, that's where the measuring
So,
that
but then
would come in, and we'd have to be
right, but
there and sit something
the other
here.
problem with parallel rays is that that's only used. Parallel rays is only used to assume the radius of the Earth. But when you go on another topic of the umbra and penumbra, then you have to have crepuscular rays. You can't have parallel
And
rays.
penumbra, what's that? I don't know what that is.
That's when the
Like winter and summertime, you talking here?
no, it's like the solar eclipse or lunar eclipse, right?
Okay, so why would we have to? What? Well, no, that doesn't. Why couldn't it work with that?
Because they show it not being parallel.
They show it not being parallel. How? Oh, I see what you're saying on the models. On the models, because no, that's because this in the model, the sun is so much bigger. So yes, even though it is farther away, it's still much bigger.
Well, yeah, that's what they say, but
I don't. So I know what you're saying. Like when the moon comes behind, and it shows like the lunar eclipse, and it's like, okay, it'll be red because the light. And I'll be 100% honest, that's confusing to me too. I don't quite understand it.
yeah. So like this image, right?
Yes, they got the lines crossing. Yes.
Yeah, but they have them coming in and they have them coming out and crossing and all this other stuff. So then what you get is you get contradictory stories for only the specific.
Is that what they're saying,
to...
though? Is that what they're saying, that the rays aren't parallel? Should we look more into this and not just take the little picture? Should we actually say that they're saying these rays aren't parallel?
The problem is that it's all just cartoons because there's no
No, we should dig more into it.
Well, no, I know, but anything that you look for umbra penumbra, they'll only be the cartoons, like this one here in the upper left.
Let's click on one and read about it. Let's read a little bit about it.
I'll see if it can pull up bigger.
Parts of the moon's shadow. Yeah, and I see, and that's okay because the moon is farther away, making a smaller shadow, but it's also making a big shadow.
Okay, how's that one? Oh, I didn't. Man.
Sorry. Got to run my ass over.
It makes it a little finicky on here. It's better to download the image and then try to zoom in on it. But what I'm saying,
no, I don't mean zoom in on the image. I mean, click on the site. What is the site saying? What is the
I know
website? I want to read about what they're saying, because if they're contradicting themselves, that's a problem. That's 100% a problem. So I want to read where it says they're not parallel. I don't just want to look at a diagram and assume that they're saying it's not parallel, because I can't just assume that they're saying it's not parallel. Just because I don't quite understand what those lines mean. If they're saying yes, the lights are parallel in order to measure the shadows, but they're not when it's a solar eclipse, that is a problem. 100%, I agree.
All right, hold on. I gotta let the thing bring it up in the different site. And
yeah, no, and then I guess I could look into it myself later. It's harder for me to do it on my phone. I don't even know if my camera disappears when I go to look it up. Oops, I can't change the website I'm on though, because that's
your camera disappears when you get on the.
When I do that, all right. I mean, yeah,
which is fine because you don't. I mean, you could if you were on a computer. I don't know how you do it on the phone. I tried to do it on the phone one time, and it was just.
So when you send me the link, I have to. You can still hear me, right?
Yeah.
Okay.
Yes.
When you send me the link, I have to copy it. I can't just click it. Well, when I click it, it says if you're on a phone, you got to copy the link and put it in Safari.
Right.
Umbra and penumbra.
Of course, they got here not to scale. If drawn to scale, the moon would be 30 Earth's diameter away from Earth. Well, the sun would be 400 times that distance. Okay.
Yeah. So we're gonna, in order to disprove it, though, we have to say, okay, this is what it is. Like, let's assume and see if it doesn't work, and if they're contradicting themselves. I can't just say out of the gate, oh no, that's wrong. I want to see how it doesn't work.
No, I know. All I'm saying is when you look up for umbra penumbra, you'll never get and there might be one out there, but you'll always have the big sun, you know, and then the moon, and then the Earth. But it brings it to another. What it does is it brings it to another whole area where all this has to get either validated or debunked or whatever, right? So,
Yeah, which we could probably do with a light. I mean, we can't
well,
create nuclear
I mean,
fission.
I just I don't want to get into it all, but you can see like how the sun rays are coming into triangles, kind of, and then
Yeah, the focal points I see, and I'm
yeah,
not sure what that means though. I
right.
see
So,
that they're illustrating that way,
but
but I don't know necessarily what that means.
right. So what you have then, what I'm saying is the cartoon for Eratosthenes, because that's all it is too, is the whenever you look up the Eratosthenes thing in it, it'll have parallel sun rays coming in, right?
Yeah,
Whenever you look up the Umbra Penumbra, it doesn't have parallel sun rays. So those two things by itself, and we can
in
say,
the
oh,
yeah,
just in the I'm saying in the cartoons that they post,
but
because
it's
you
not
can
just the
actually
cartoons
see.
though, because when we talk about Eratosthenes, they say that the sun's a, so when Sagan explains it, at least he's saying that he did make assumptions. He made an assumption that the sun was very far away, and that that the Earth was round. Those two assumptions I do believe.
And the
So
parallel
he
sun
assumed that
rays.
since it was, well, because it was so far away, that the rays are coming in parallel. So that was the assumption there,
Yeah.
like
So,
too,
but
as well.
then you get to the Umbra and Penumbra, and those are assumptions, and that's a whole nother topic. But all I was doing was pointing out when you talk about two different aspects of the globe heliocentric model, you have to
Yeah,
have different different things to go off of.
it's a
So
slightly different illustration, yes. But like I said, until I hear an actual someone say, "Oh, well, they're not parallel when the eclipse happens," that's until then. Because if I hear that, then I'll be like, "Oh, okay, yeah, something's wrong, something's wrong." Because then they are
yeah.
truly contradicting themselves.
Now
I'm not assuming they're contradicting themselves; that they
it
are truly
depends
are.
on who, like you know, me and you talking, or some globe proponent that's making YouTube videos is talking. Like if you hear him talking, and then if you hear like Neil deGrasse Tyson say it, right? Those are three different categories, like, of people talking about it, right?
I
So
guess, yeah,
is
and
because me and you are just going to be normal people. Yeah, I make videos and stuff, but I'm not making. I'm not primarily what I do on my own is I make videos about the Bible. But
okay.
the talks like I have with you are the videos that I'm not putting anything, you know, I'm not making a video to show this. I'm just pulling up graphics online while we talk. But so then there's people that, you know, there's people, flat earthers and globers, that make these videos to show people, like the videos I showed you, you know,
Yeah, no,
or that are,
absolutely. And who knows? At the end of the day, I might say, "Well,
but
shit,
yeah, so
I'm
it's
with you."
just you know, you can say it's on either side, it's just a YouTuber, right? Whether the information is correct or not, it's up to you to decide. But then when you have like a you know, the authority on the topic, like Neil deGrasse Tyson saying contradictory stuff, you know, like he
Yeah, and
said,
that's what I love to see. I want to see his contradictory stuff. If you
right,
show me someone like that that saying contradictions, I'm really gonna dig into it. I haven't seen it, but I would love to.
yeah. So is the Earth, in your opinion, is the Earth a near perfect sphere? Is it a oblate spheroid where it's scrunched
It's a
out and
near perfect sphere,
it's not a
near
paraphere?
perfect. So if you were to measure down to the millimeter, yeah, there's different. Absolutely.
But would
And
you
he even
say it's
said that in the
parasite?
same interview. He said that in the same interview, cosmically speaking,
Yeah,
the
yeah. So
Earth
he has to
is
do
a
that. That's
sphere.
what I said. He has to
Well,
do
because
that
that's
all
what
the
science
time.
is about. It's about
No,
technicalities, right? It's about
no.
getting the
Well,
technicals. It's not about, well, this thing down here, it looks like it's circle, but if I really truly measured that, it's probably not a perfect circle. And that's being technical. That's,
well, you're talking
that's
about two different things. You're talking about the Earth or something on the floor, but
what's
you
the difference?
in order to make an argument stand with the globe propaganda, you have to shrink it down to the size of a cue ball.
Well,
And
because
so,
that's how scale works, right?
right, but that's all assumption on the cosmic
Well,
scale of things.
no,
But
okay. Well, so no. Because that isn't an assumption. Because now, like, if I take a microscope into something, it's smooth. It's smooth. This. But if I look at it with a microscope, it is not. It is rigid. It is rough.
Yeah,
Nothing is
that's
smooth.
going down from where you're at, but
Yeah,
taking
but we can
something that's
also go
bigger
up.
than what you, but we can't do that.
Well, yeah, well, we can because we can see. Okay, you're right. That's now I'm assuming that the planets we're seeing, Jupiter,
Right,
Saturn, their moons around them. I'm assuming that they're already big, but we see these things that are very, very, very far away. But in a smaller
right.
example, is in a plane, when we get up in the air and we see a street, even or rows of houses that look like these neat little things. Another great example is uh, not computer science. What the hell am I like chip making? When they make the chip, like with the silicone and stuff. When you look at those and you zoom in on those, they're
Oh
like these
yeah,
whole little cities. It's insane, dude. All the transistors and stuff. It's
yeah,
amazing.
for sure. But in microscopic, that is microscopic.
And the
The
macroscopic, they're
globe.
two different. They're very, very similar. Now the only time that they get a little dissimilar, which everyone kind of agrees on, is when you get really, really small. Then their theory of gravity breaks down, which is a problem. I agree with that 100%. That's why Einstein was trying to get his theory of everything to make the quantum and the macro fit. Because right now it doesn't. There's something missing.
Yeah. So what was it that you were wanting to what experiment or whatever you were talking about? Was that the measuring
It was the
sun?
the sun and the star. Because
Oh,
if
okay.
the sun, which is bigger and closer, but we can still see Polaris, I do see that as a bit of a problem.
Oh, right. And that's what I told you earlier was like understanding the what before we can understand the how. So I can measure that, and it goes back to that for me. I can measure the ground myself, right? And I
Yeah,
can
I mean, I've
measure it
worked
a
in
hundred different
construction, and
ways.
I've had to grade the ground. I've had to give it a bit of a slant. I've had to make it completely flat and level.
For what?
For construction, I've done construction, and
Yeah,
so I have to
yeah,
grade the
construction,
ground.
right?
I gotta,
Yeah.
yeah. So 100%. But
So in
on a scale bigger, things change a little bit.
so
Even if the Earth
uh,
wasn't round, things would still change on a bigger scale.
yeah, doing that experiment where you can measure the distance on a measure the height of a light source. That's been done. You could do that. I mean, that's not a
Well, then let's do
uh,
it, and let's try and see how far away the sun is.
well, you want to measure
I'm also not running
a
away
shadow.
from. I have a basketball at home too. I have a basketball at home as well. So I'm not running away from the mountain shadow underneath. I'm gonna finagle with that too.
Okay, yeah. So
That'll happen
I
probably
was gonna
since we
send
won't be
you
able to
those,
stop for
but
a couple of days.
you could go back on the project analyst and go in there
Oh,
and
I was
look at
looking. I did see his paper. I see what you're talking about.
yeah.
So yeah, I don't know how he's supposed to. He's on the ball, but because the same could be said for the not the paperclip. Well, yeah, I guess it is a paperclip. And the cloud, because there's no way compared to the actual globe you have that cloud was as high as the whole state of Washington.
No, no, my cloud would have to be microscopic. Yeah.
Well, yeah, same thing with the paper. But what he was trying to show, and yes, his laser was way too close, 100%. It was shining. But if there's a line of sight from the source, so it would need to be a bigger laser and a bigger light for sure. But if he backed it up, same thing with you, your line. I loved your line because if you draw a line perpendicular to the equator, like straight up and down, the longitude line, like for 0 on your globe, that's like at the degree the sun travels, like through the globe. Your line that you had.
Yeah. So yeah. That was just a line from
South America
Seattle
up
to
to yeah.
Sao Paulo. Yeah. Because what I was
Although,
trying to
actually,
do
no, it might have
was
been different because if it's in the wintertime, actually, yeah, I don't know, maybe not.
well, I picked the some winter solstice just so we could have a reference frame from where the sun would be, like more precise. So
Yeah, I gotcha. But if you back
What
the
was I?
light up, is what I'm saying. The light would
Yeah,
perfectly hit Sao Paulo dead on while just barely coming off the top of the globe where Seattle's at.
yeah, but it doesn't. The problem is that the light dissipation didn't work well, and I couldn't get under the. Even if I raised the cloud, and I messed around with it for a while before I made the video, and I couldn't get the light to even go under the clouds at all. But and that's only considering, the smooth reflective ball that I have, of that globe, that toy globe that I have,
100%,
without even actually.
which is actually, so, and again, I'll make the assumption that globe is actually a lot more rough and more or less of a perfect sphere than our globe would be if it were actually that small. So, especially where the wood is concerned, it would be just as reflective. I forget what the actual albedo of it is.
Oh yeah, so and again, that's what I was talking about. Reflections. Another area of something to look into is how light reflects over over a curved surface or over a smooth flat surface, or a flattish surface, right?
You're speaking of the hot spots.
No, not the hot spots.
No, not the hot spots. That's one I got before about, oh, how come the moon doesn't look like doesn't have a hot spot on it? I don't know.
What I was talking about was like when you're on the lake or whatever,
Mhm.
and you see the light coming to you. Let me pull up an image here. This one will work, I think. Yeah, this will work.
Oh, I wonder if you could actually see my laser on the video. I know there's got to be something I can measure with this thing, although it gets extremely wide the further you go out.
What's that?
My laser. I love it. I love the little guy. It's like $20 on
The laser?
Amazon, and it's one. Yeah. I'm gonna hold on. I'm just pulling it out of my backpack. I'm gonna shine it up into the trees here. Oh shit! Did I just drop something? Oh. I'm gonna shine
Oh
it up
yeah,
into the
I have a couple
trees.
lasers myself.
I try and get to a darker point, but can you see that?
Yeah.
Like the actual beam of it?
No, just the dot.
Just the
It
dot.
has
You might.
the beam has to be on something in order to see the light.
Yeah, maybe if I get
So
like.
if you had baby powder, you could. Now I could see
Well,
the
no,
beam
for
a little bit
you
more like that.
on the camera,
Mhm.
yeah, for you on the camera, it might be harder to see, but me personally, I
Right,
could
right.
see it like amazingly. That was like my whole. I'm sorry.
Yeah, I
So
could
that
see
was like my
the
whole point.
beam a little bit.
Yeah, it's harder to pick it up on a camera.
Right, but if you had
But
baby powder, you make a screen that all the light things can hit.
yes, then
Which
it's
I
much
which
easier
I
to
did
detect.
a small experiment with that. How like if you were to use baby powder like a cloud, I was trying to get like the fog machines that you get for parties.
Yep.
Well, they have
You can get some
machines that
dry
also
ice. They
work
gotta
like
have some of that up, and that's good.
they have some of them that work like clouds, but they're really expensive, as opposed to
Oh,
fog where it sits down on the ground. And
okay.
I didn't want to put the money into it, but I wanted to. It would be interesting to buy one of those and do like a simulated cloud with
Yeah.
different.
No.
But I'm not spending $600 on a cloud machine, so.
Yeah. So I was actually looking at the spectrometers as well on Amazon, and they're like $600 too.
Right, yeah.
Um.
Look at this. Look at this here. This is just a still shot, but so this is what I'm talking about right here. The you got the sun, and then you have
Oh, the reflection off of
the
the sun.
reflection comes to you. Now, if it was curved like Carl Sagan curved his little metal cardboard thing or whatever it was, it wouldn't
Yeah,
do
which
this.
and yeah, I'm not. I don't know actually. I'd have to look more because I don't know personally
Well,
if that's the case. I'm not an expert on the way light reflects and the angles it
yeah.
actually goes. I
So
would like to
just
learn,
take
but
even with your laser, if you take like a metal, something metal or reflective, like a um Well,
Well,
just a
so
sheet
I
of
would
metal,
have to put,
aluminum foil or
yeah, and if
something.
I would have to put though, so if I did take an aluminum foil, the amount of bend I would have to put into it, even if it was the size of a football field, would be so insignificant to the actual curve that they say is the globe. So
Well, that would be assuming a much larger globe than what would be
yeah, I
apparent
mean, especially if I took a
for
sheet that was
because
just like a 4 by 4 foot sheet, I wouldn't be able to even bend it in any type of degree that matched the globe. That they say is, you know what I'm saying? So like I don't even know how
well,
it would
no,
fix them.
no, I'm just saying you're testing the reflectivity of a material over a curved surface or over a flat surface. That's it. So like if
Okay.
this, let's say this tree here, it's not. I know it's not, but let's say this tree is 10 miles away, right? Or
Mhm.
if it's 5 miles away, it doesn't matter. If it's 5 miles away from the observer, the you still got the bulge of the Earth, and it's still going to curve around. And even that distance, that short of distance, the light wouldn't come to you. It would stop at the bulge of the Earth. Now this is
I
higher
see.
up, but
Yeah, and
but you can,
obviously the sun's still up
yeah. I'm just
in the
saying
air.
every and then every observer, this reflection of light, this is not actual light, it's just a reflection. Every observer comes to the personal observer, and not it's not so all that light comes straight to the personal observer. So if another observer was like to the left, he would see his
Yeah,
own
it would
personal
see the
reflection.
same thing. Yes.
Right, but you can't you
That's
can't you can't replicate that on a curved surface.
I mean, I don't know. I guess maybe I've never tried. I don't. And again, I'm sure to some extent you can. It all depends on the significance of the curve.
No, yeah, I could. I mean, we could
I
probably agree
mean,
on that. Yeah.
it just depends on the significance of the curve. But I 100% agree that
So
that's I don't know. It's coming straight across like it looks flat, and I'm not going to sit here and argue either that even when I'm in a plane, does it look flat? It looks absolutely flat. But so do those lines when I pull up on my phone. Are these lines straight or are these lines crooked? Well, they look squiggly as hell, but apparently they're all straight. So the human eye is not one to really trust that well. And that's why we, do these things and try to measure and try to repeat and replicate and see.
yeah, right.
I think here. Yeah, so I want to do
So
the
there was
mountain
this
one.
one guy. This one guy was trying to replicate what the light would come in on the Earth, right?
Mhm.
Being a water ball that it is. And he made it was pretty cool what he did. He took a balloon and filled it up with water, and then he put food coloring or something like purple food coloring to make it dark. And then he
Okay.
did a demonstration where light, what we're talking about, light going over the curve of the Earth. And so he made a whole ball of ice like that. So then you got the reflectivity, and it did the same thing what I'm talking about. It didn't reflect. The reflection didn't come to the observer
The
in that
observer.
demonstration.
That's yeah, I mean, I'll check that out for sure. That's a hard one to pull off because then you got to consider scale. Thank you, sir.
Well,
Appreciate it.
well, if you can, if a glober can scale down to the cue ball, right,
To the well, yeah,
and say that's
but that's not
legitimate, then we got to be able to have that same leeway.
well, no, because when they're saying they're scaling it down, all they're doing is taking the values of okay, there's an 11-mile difference. It's an 11-mile difference between the Mount Everest, the Mariana Trench. It's an 11-mile difference, and if you take the whole, circumference and the radius and all that of the Earth, 11 miles out of 25,000 or whatever the hell it is pretty insignificant. That's what they're doing. That's not them just saying, "Oh, here's the model, believe it." There's the math is behind it. Hold on, I gotta shut my damn.
Oh yeah, but uh, math
Yeah, so it's like ratio, like the ratio of something like they build these things all the time, like models. Okay, this is a scale model of a B-2 bomber, but it's scaled down, you know, 100 times. But all the ratios on it are correct. The door is the exact same size it would be in comparison to the rest of the plane. That's all that they're saying. Obviously, no one's been
Oh,
big enough to grab the Earth and say, "Oh
we
my
lost
gosh,
signal
it's
for a minute.
smooth." Oh, I wonder if it's trying to connect. I'm in the damn
So
house.
did you? Yeah, it was. Can you hear me now? Or
Oh, I can hear you. Can you hear me?
okay, yeah. So I was
Can
saying that math in itself is not reality, but it can describe reality. But so what they do is make math the reality, and this is my example of that. So one of my bank accounts that I have $1.5 million in there, and I could give you all the math to show you how I got to that point, right?
Yep.
So I can show you how my APR and my compounding interest and all that stuff, and how much I put in there over the course of 10 years. And I can show you how, I can even show you bank statements that say that line up with what I'm saying.
Yep.
But that's just a math equation because I don't actually have a bank account with $1.5 million in it.
Okay, but see, then that therein lies the problem. If we go look at your bank account, well, then you were just lying about the numbers. Men lie.
Well, what I can
Numbers
say
do
is
not lie.
I could show you bank statements that say that, right? And I can show you all the
Yeah, and
numbers
that's a
that say that.
fabricated bank statement. And then we would then say,
Yeah.
okay, well, follow the evidence. So it's not like people are just pulling numbers out their asses. The
Well,
numbers that are being used
it has to appear to
to,
work, is what I'm saying. It has to appear to work, but that doesn't make it reality. So you can have all the math you want in the world,
yeah,
and
but
it's still
math and
not be reality.
geometry, algebra, all these things, they are reality. Like
They're used.
the measurement of
They're used.
shapes.
A
the-
a times a times b minus q x r t is not math.
Well,
It's
yeah,
a
because those variables
it's
have no
an
meaning at
equation.
that point. But if you
All right.
plug in the variables
Yeah,
like
yeah.
this,
You
like
have to
to
plug
figure
in.
out something speed, that's a
Right. You have to
complete
plug in something tangible though
absolutely, and
to
that's
make
what
it
we
mean
do.
anything.
That's how we
Right.
make it reality.
Well, yeah, but you can't say that's the thing with the whole 93 million miles thing. There's no reality to it. It's just a math
Yes.
equation.
So I can't personally measure the parallax between the angle when Venus is in the sky and the moon and the angle. Me personally can't. I'm gonna try and learn to, but I can't personally do it. How you doing? I'm doing well, thank you. But I know people can because they've, there things have come of it. Like I always bring it back to like this phone that I'm holding is a result of STEM. Thank you, Daniel.
Yeah,
I'm sure.
I know what you're saying, but
But that comes back to
there,
someone speaking
but
Mandarin. I
just
don't understand it.
having a distinction between what is physically measurable and just what is like the whole string theory thing. It's just a
That
theory
yes,
to make people try to understand what another theory. That's all it is, right? It's just one theory built on another
yeah.
theory.
And so you're jumping now though from basic algebra and geometry all the way to string theory. You just skipped calculus. You just skipped
No, no,
trigonometry,
I'm just
and we're going to
no,
string
I'm just
theory. So of
saying.
course we're not going to understand it. You don't teach kids multiplication first before you teach them addition, and same thing with exponent and then algebra. There's a just like you were telling me
Yeah,
your guy built up to where he was at with his model, Joe.
Joe Hanby.
Yes, he. You got to watch him and all the times over and just getting it
No,
better
I
and better.
know.
That's humanity. That's
Yeah, I
math.
know.
That's I mean,
But
we got
string theory. What I'm saying
developmental
is string theory is just math, but it has no substance to it. Is what I'm saying.
like and all these are all like they do have substance to it. There's reality in all these numbers, even though see that's what I was talking about earlier. Well, I wanted to go back so we can agree if I take one thing, two things, and then here's two more things, and I add them together, we got four things. So like we understand that, we get that concept, and I want to go all the way up through the different things taught to where it turns into pseudoscience. I would love to find that. Because I don't know
Yeah,
much
and
about nothing either.
I would start with the measurable uh, curvature of the Earth. That's where I would start, and then
Yeah.
then I would go from there.
Well, no.
Because,
Okay.
like I said before, all the other stuff doesn't really matter if you're never going to measure the curvature of the Earth.
Yeah, but you're not. But see, you're refusing to accept that the curvature has been measured, and I can understand that.
No, I
And then
measure it.
that's why.
I measure what they tell us.
No, I know you're
That
coming to the globe
so
calculator and how
you
much curvature should be gone. Yes, I. And then refraction
so you
is
see
good
this.
sometimes, so we can see the sun go beneath clouds. But refraction is not good, so we can see over the horizon. Is also another unfair thing to do. And me, I don't know either how they work. I was watching one about this because I'm curious. People are saying I
Well,
watched the videos you showed me.
refraction and magnification are a little bit different. So can you see that image right there to the right there? I try to make it bigger, but it won't let me.
Hold on, I can turn my phone. Yep, the horizontal line. Yep.
Yeah, so this is showing the lake,
Oh, I can zoom
which I
in.
showed you.
Sweet. The reflection on a curb.
Yeah,
The
so this is
reflection on a
just kind of
plane.
showing you what I was talking about, right?
Okay.
And you can play around with the curved surfaces like that, but
Although those are
so
different, I'm seeing because the one was it got very narrow, and the other one, at least in the illustration. So the reflection on a plane, you see that, right?
yeah,
And you see how it's zooming out. It's narrowing towards the observer, but the actual picture is getting wider towards the observer. And I'm not saying that means anything. I'm just saying,
yeah.
okay, there's something different.
Yeah, yeah, no, that's
You know,
another observation that you can see. And there's sometimes with like the video I showed, it looked like those the sun reflection was parallel. It looked like it in that video. But the point is how it works over a curved surface, the top image there, and then over a plane, it more matches what you see in reality with the sun and coming across the
and
lake.
I will not disagree with that. Actually, I will 100%
Anyway,
agree with that. You're absolutely
that's
right.
just something else to look at. Like how can light reflection, not refraction, but reflection
So, do you have your
come
globe with you?
to us? The what?
Your globe.
Yeah,
I don't have a globe.
yeah.
All I have is a freaking basketball.
Hey, I got my globe with me. I love my globe.
So, and I'm like, look, I am about the truth. So I'm trying my hardest. It's hard to take what I've learned and kind of throw it out. But I know you can't
Yeah,
fill up a whole
sure,
cup
yeah,
while being full with everything.
yeah.
But if I want to truly say, okay, like the mountain thing, is it flat? Well, let's show how it works when it's flat. Is it round? Let's show how it works. Let's test it. But anyway, why I was having you bring up the globe was because I checked out those pictures about Boston from Cape Cod. They're actually pretty interesting. I saw a couple of them online where you do just see the tops of the buildings.
Right.
And now I want you to point out, can you at least agree that the globe right there is, if they say it is, it's at least to scale? Like,
This,
yeah.
like to the scale of the
Like
Earth.
Alaska, the distance, the time it would take you to get from Anchorage to where you're at in Fairbanks. Roughly to scale.
No, this is not the scale at all.
So, okay. So you're saying for
Like I
where
can't
Fairbanks?
because I can't measure
No, I
those.
know
You can't measure those distances, so I can't tell you
there's
if
a
it's
scale on it
or
though,
not.
right? There's a scale on it, correct? Somewhere there's a scale on the globe usually. There's a little line that'll say this is 100 or 300 or 400, 500 miles.
Well,
An
the scale
inch.
is 1 to 56 million.
That's what it says.
Yeah, 1 to 56 million.
And then there should be a scale around there too, right? It'll say, an inch is equivalent to 500 miles or something, right? I don't, because I can't do that
No,
math on the top of my head.
it's
One to
just saying
56
that
million.
this globe is one fifty
Okay.
six million
So the
of
curve,
the
what I want you to do is look at the
Earth.
northeastern United States.
Huh?
Look at the northeastern United States.
Yeah, like
Massachusetts. Now point out Cape Cod.
No, you can't see Cape Cod at all on there.
Because how small it is and how close Boston would be. Now, what is the curvature of that lake? How distinct is that?
Uh,
See, that's my point. It's 50 miles from Cape Cod to here, but 50 miles on this, which is small, which I do believe somewhere on the globe, there's going to be a thing that says an inch is like 500 miles or whatever.
Yeah,
It
no, I
may,
don't.
all right, well, I'll do that math later on the. I'll have to divide 225,000 the circumference, whatever. I don't know. There's some way to get to it. To get to show you how an inch is what an inch would be equal to on that. Like all maps have that. They have, okay,
Yeah,
that's why you use compasses and protractors and stuff to get the actual
yeah, but
distance and map
none
things
of that
out.
works on a globe though. Compasses, protractors, none of that work on a globe. You have to use a flat map to even navigate with a compass and a protractor.
Well, yeah, that's because, and this is my point, is the amount of distance we're going to be traveling is unless you're in a plane, even when you're driving a car, you're thinking, okay, it's a straight line. But planes fly in geodesics. They fly in the shortest path over a curved surface. That's why on the flight thing, they look like they're going all kinds of wacky areas.
Well, yeah, right. You should ask, that's what you should do. You should ask a pilot be specific when you ask it. Don't say anything about like the flat earth, but ask them
No,
when
100%.
we fly from Boston to wherever,
So
Los
somewhere in
Angeles.
Europe would be good.
I mean, you can
Los
say
Angeles
Los
too.
Angeles or whatever, because ask them, do you just get on a course and set the course and go and let the autopilot kick in? Because that's
Oh,
what
they
it
do.
does. I mean,
Oh yeah,
yeah.
they
So
do.
they fly planes fly from point A to point B in a
On themselves,
generally
pretty
straight
much.
line. In a generally straight line.
Well,
They don't
yes,
you
but
don't
it's
get
not a straight
deviation.
line. Like that one dude that always frustrates the hell out of me. He's saying, okay, a flight from New York over to Paris or whatever the hell, and he's drawing it. How? It doesn't make sense. And he shows the actual flight path on a flat simulated map, and it's going over, like Greenland and stuff.
Right.
And that's because though, if you draw that same line on the globe, it works.
Well, so the one that's the flights that go from like the West Coast over to England or something like that or whatever, and they say they fly up on the Great Circle route, right, or whatever,
Well, the
and
geodesic, yeah.
so they say that, and then that's how they get it to go up to fly under like over Greenland or whatever. But then on like on a flat Earth map, it's actually just a straight line.
Well, yes, in the northern hemisphere, but where it goes all haywire in the
Yeah,
south.
so we could look at different. I mean, there's a different. Hey, you should check out. You should check out this video or this book. I think you can download it for free. It's called 16 Emergency Landings That Prove the Flat
16
Earth.
emergency landings. Okay. Oh no, and I've seen some of the videos about the emergency landings that
Yeah,
when
but
they
in the
try and
book you
show it
can
on their
do it
flat
yourself.
Earth, it looks yeah. Or when they try and show it on the globe is when it looks weird. But no, I'll check the book out. 16 emergency landings that prove the flat Earth. I mean, I like my books. I have a lot of books.
I think you can download it for free.
Yeah, I'll definitely
But
check that out. I do like a good old fashioned book in my hand though.
if you want it like on hardcover or something, you gotta order it from Lulu.
Okay. That sucks. That doesn't just have it at Barnes and Noble.
Yeah, right.
All right. So
I was gonna.
flight, okay. That's a hard topic too, flight paths.
Well, and
But
and I think that's another one that you could use both ways if you really
the
wanted
southern
to. But
hemisphere, the southern hemisphere, you can't though. That's the main problem with the model of flat Earth is when you do flight paths in the southern hemisphere, they all fall apart. Same thing with the light, the way the lighting works during the season, unless you assume a coffee cup caustic, which has never been proved. What? Okay, let me ask you this: come December, when they see a 24-hour sun in Antarctica, the flat earthers that are going down there, I'm pretty sure it's Austin, and I don't know the other guy's name, and then the two other guys.
Jaron,
What's yeah, what how will that make you feel? Like, what will that change? Like, okay, maybe I should look at some different things. Could I will genuinely, if you point out a contradiction from any of the other scientists, will like question it. And I'm gonna look into the Umbrian, whatever, the
Number,
rays
number.
for. Yes, I'm gonna look those up because yeah, just
This
by
thing
those
is saying
illustrations
it's
alone, something's
$49.
off.
I didn't know it's $49. That's crazy.
Holy hell. Okay,
Just
16 emergency landings that prove the flat
just
Earth.
download it for free.
Yeah, I'm sure I can find a way to get it. I'm sure there's
Yeah.
someone on YouTube talking about it too.
No, yeah, but with everything, and see the problem I think with saying a flat Earth model is because a flat Earth model or flat Earth map or whatever, you don't need a model necessarily, or there isn't going to be necessarily a model for that because we can't. The problem is we can't actually measure all the distances of the Earth. We can only take that at face value. Now we have to, right? Like I can't measure the distance from I haven't
Who will you
measured.
trust though?
No, I'm
Unless you
just saying
do it
you just
yourself,
gotta
which is unrealistic though.
right
Who
there.
would
And
you
there's things
trust?
that's what I do. I can validate things for myself, and then those things that I can know that align with that particular thing. Then I can
Yeah, which
trust
is
it
why
more.
I
But
want to do the measuring of the
there's been
light.
people that the what?
Which is why I really want to do the measuring of the light because that's something we can do and we see the math is right. If I want to figure out how far away that light is up there, I'd have to obviously shut all the other lights off to measure the exact
Sure,
shadows.
and
I
use
put okay,
try
I
to
got a
use the
couple inch
shadows to
stick
measure, right?
and I put it here and I measure the angle and it gets me 11 feet or whatever height that is. And then I measure that with a tape measure and say, okay, that's 11 feet. So obviously the system of trigonometry and Pythagorean theorem and all that works. I can do
Right.
that with the sun, and we'll assume both ways. We'll assume it's local, and we can measure it like it's a distance. The problem with that comes in that okay, now that means when it's moving away, it's going to be extremely far. When it's 12 o'clock for somebody else, that hypotenuse now from my angle is like double if it's almost sunset for me, and it's 12 o'clock for somebody else. Which means the sun should be getting smaller, like all objects do in reality.
Yeah.
This is why I want to do it ourselves, so we can say, okay,
Yeah.
then it must not be.
So that
It
can
must not be
that can
local.
be done like you can measure oh, that's what I was getting at with the sun, is because if you're measuring it from where you're at and I'm measuring it from where I'm at, and because the sun is coming in at us differently, it's not going to give us, you can't
Yeah,
really triangulate.
we're not on good longitudes. No, I know. It would have to
but,
be
but you can't really triangulate where the sun is. You can only triangulate, it makes it difficult because we see it differently at our own position. You see the personal atmospheric dome thing Stephen
well,
Alonso
no,
does.
because I don't know what that is.
So
We all
okay, so
see,
when you
yeah, if
see
refraction,
when you look out though, you can see a certain distance in a direction, right?
yeah,
And then you look to the left, you see that same certain distance, right? Unless something's obscuring it, but
yeah,
so let's say you could see a mile in one direction, and you look in the other direction, you can see another mile.
yeah.
Well, that's your personal atmospheric dome or whatever you want to call it. How
My
far?
vision, my perspective.
Yeah, right. How far you can actually see something. So
Yep.
you're in a different area. I have a different personal domal perspective than you do.
Well, yeah, but that's why we measure it because so.
No, I know, but the sun that we're seeing is inside of our personal atmospheric dome. It's not.
Yeah, but if I know
tangible
the
to
distance
us.
between me and you, if I know the distance between me and you, and then now I have that distance, and then we measure the shadows at the same time, and again, we have to be on the same longitude. So we know the distance between me and you, and then we measure the shadows. You have a different shadow than I have. We can then determine how far away and the angle that that thing is coming from. Well, we get the angle, which would
No, I
then lead
know.
us to how far away.
I know. What I'm saying is that it's not going to be accurate like we think it is. Because once you start
Why not?
triangulating, because you see the sun, and that's what I was getting at with the.
There's only one sun, though, that you can't, because now you're trying to say that there's more than one. There's only one. If I have the basketball up here and it stays here, and then someone is over to the left of me and they see it that way, it's still in the same spot for both of us. It's relatively, it might be a little closer to me than it is to him, but that's the point. That's we're trying to get that distance. You,
Yeah, I know. It, and that's something. I understand what you want to do, and I think that that'd be interesting to do. We have there's this one page. It's called Firmament Trackers.
mhm.
Okay, and what a lot of them do, they'll pick a time, and they'll say, "Hey, let's all look at the sun together and see what we see."
Okay,
So people are doing what you're suggesting. People,
and they're
many people are
measuring.
doing
Because I know,
that. Yeah, they're
I
measuring.
said, I looked up the whole Eratosthenes thing, and again, they weren't assuming, they weren't trying to measure the distance of the sun. They were because they were assuming that the Earth was round, so they were just measuring the shadows to get the circumference or the radius rather. But if we assume it's flat, which this was all been done in the video, but I want to do it myself. It's all done in the video I sent you. The guy assumed it was flat, so he measured the distance to be like 6,000 miles away. And
The
if
sun.
it is that close relative to us, when it instead of being at the distance he just measured it, when it's all the way somewhere at sunset, it would be like 12,000 miles away, which would
Right.
make it relatively smaller. But someone over there is still seeing it at the same size, and I'm still seeing it at the same size. I guess what I'm trying to figure out is the personal dome. How do if, like even at the airport, if I'm seeing an airplane coming in, I'm obviously seeing it a little closer. And then there's someone
Right.
in a different part of the city over there is seeing that same airplane come in. They're seeing it a little bit differently, but that airplane still has an actual location in space that it's taking up. It's not
Right.
different for both.
Right.
The distance is
And
different.
something that is different though is uh in in and I think the more people understand, the more they're trying to get to a certain point. But the the mindset of the sun being physical is only a globe mindset. That's not a flat Earth mindset.
Well, then let's find that. Let's
Well, I'm
find
just saying
out what it is then.
it's too different, right? It's two different mindsets. So the sun and moon are not like physical things, physical
And that's
objects
what
like a
gets me
car or a
about
plane.
that's what gets me about Dave is because in his years past videos he has said, we see an Antarctic sun, I will reevaluate. But now that he knows it's coming, he's literally saying, well, that doesn't mean nothing, and the sun is just a magical thing now instead of that's
Yeah,
not fair.
I think that I mean you can also again if there's a 24-hour sun in Antarctica, an actual 24-hour sun, because they do have sun simulators, right? You agree with that? Like, they have sun simulators.
No, I don't agree with
Okay,
that at all.
so
Where?
look it up. They got a patent for it and everything. Even China, like I want to say 5 years ago, um, they they were doing experiments with Sun Simulator.
Sun simulator, also known as a solar simulator, is a device that produces light that mimics the sun's spectrum. Solar cell testing, calibrating and testing the efficiency of solar cells. MBJ backing solutions. Solar simulator, NASA spinoff. That's hilarious. Okay, yeah, but it's not a device that's up in the air.
Yeah, it
It
is.
it well, okay, not the one I'm seeing.
It can be up in the air. I mean, if so you know how
Yeah, it's
you
like the
know how you're driving down the
hexagonal
road.
lights.
Yeah, but you know how you're going down the road and you see a headlight, but you can't make out the car or anything behind it.
Yeah, absolutely.
So if the light is bright enough, you can't make out anything that's behind it. So if there's a sun simulator attached to a you know plane or whatever,
I'm
and
almost positive though that these guys are gonna have at least one of them, definitely the flat earthers, but I'd even be willing to say that the globe earthers too, just so they can't, just so they can't let the flat earthers use that as an excuse. They're gonna have solar filters, and you can even measure the sunspots on the actual sun, and then look at the sunspots down in Antarctica, make sure they
yeah, but
match.
you could. All I'm saying is there is a sun simulator, right? And you can project. You can project images they're doing that. They're doing all that 3D projection, hologram projection stuff now.
That takes a lot of equipment, 100%. It takes a lot of
Oh, sure,
equipment,
yeah.
and you can't
But
you
when you
can't just
have
shine it
when you
up in
have
the thin air.
$53 million a year to work with, you got a lot of equipment to work with.
A billion, actually, I think.
Uh,
I think it's like 35 billion a year. NASA budget?
Oh yeah. I was talking about a day.
Billion.
Yeah.
Oh, okay, yeah. That might
But
equal
anyway,
out to you. I know it's
so there
billions over the year.
is a sun simulator, and so if there's a 24-hour sun in Antarctica, and they're just seeing it from one perspective, and then let's say they see it, and then when the sun's rotating around or whatever, and then let's say it's going out of view,
Mhm.
but they're gonna have stuff in the way, even though they can still see the sun
because
around.
the altitude is pretty high where they're at, and I'm hoping that one of them, at least, even though it might be too cold, bring a drone, some sort of camera footage where they can get up and over whatever they're trying to look at.
Yeah, I think that all I'm saying is the possibility is there. That's it. That's all I'm saying.
Yeah, and
so,
you're right. Okay, I'm not going to deny here that they can't fake it, that they could possibly fake
So
it.
what I'm saying is,
but it would take a lot.
If the possibility is there, yeah, sure. And if they're gonna do this whole trip to Antarctica and whatever, and they got all the approvals and everything's ready to go, and everything.
There's no approvals to go to Antarctica, though.
What's that?
There's no approvals needed to go to Antarctica. You just need to have the funds and the know-how to do it.
For what you're trying to do, you need it. If you're just going on a cruise, you're just going on a cruise, and that is very, very restricted.
No, you can go to the South Pole as well, like the actual South Pole.
Well, you can go to the ceremonial South Pole. And then there's 3 different ones in 3 different locations or whatever. But anyway, that's getting off track. But what I'm saying is, if it's even possible that they can make a 24-hour sun with a simulator, right?
Mm-hmm.
It doesn't change anything for what you can measure the Earth to be, the ground, So,
but it does, because if it fits their model.
Well, again, you haven't looked at Joe's sun 24-hour sun video?
No, I did. He's got the dome, though. He's got the dome, and I did watch the Star Trail too, and he doesn't explain the Star Trail, because no matter what I do, all right. So we want to talk about how things work on a globe, but if I cut this ball in half and I put stars all on the inside of the dome, and I put something over it and I spin it one way, no matter where you're at on that flat thing, you're gonna see the North Pole in the north spinning just as it would. Polaris just sitting there, but the rest of them would be going around. There's no way to get around that, and they wouldn't spin the opposite direction. Even if I go on the other side of the flat, even if I go on the other side, my ceiling, and I put stars spinning around me, they're all spinning this way. Even if I go over here, they're still spinning that way. It doesn't change it the way they're spinning. Counterclockwise.
Yeah, we discussed that. Yeah, but the stars they're still moving in the same direction, though. Even if you're south, they just appear to move in the other direction. So why do they appear to move in the other direction? That's the only question.
Because of this. If this is spinning one direction, which is clockwise right now, I believe I'm spinning it, and then I'm still spinning it the same way, but now it's spinning the other direction. And if you're on it and you're viewing it, you're looking away from it. That's the view we get.
There's a bunch of people that have demonstrated it even without a dome, and so I'd have to find them. I mean, I can't really spend.
What do you mean demonstrate it without a dome?
Just a demonstration of Southern Star Trails going around in the same direction
without a dome, but on a flat Earth.
Yeah, without having a dome. But what I'm saying is, I can't spend hours and hours looking for a video.
Yeah, no. I'll look at.
If I come across it, looking it up is hard to find. But if I come across it, I will send it to you in the message again, because I had it pulled up yesterday, and then I was going to send it to you. Then I can't find it again.
Yeah, because I think I saw the same one. It was really dark, but that was like a dome, and it's just I'm just not understanding it. And There's a
this
lot about
this
the globe Earth that I don't understand too. That I do want
yeah,
to
this
like.
one
I'm
that
gonna
I
rip
was
apart
looking at, this one that I was
the
looking at didn't
rays.
have the dome in it. It didn't mention the dome. So, but there's all I'm saying is we can go back and forth about stars and the sun and the moon and all that other stuff. But if we're not measuring the ground, all that other stuff doesn't really matter. Because when you start with a ball and explain everything through the lens of a ball, and it can make sense because you started with the ball. But if you can't even prove the ground is even curving, then I would
So
say there's no ball. So now understand it through a different lens,
So
and that
that's
takes a
why
while.
I would go with measuring the sun. And if we can measure the distance and we see that it is really 6,000 feet, then we can at least agree that if it was 6,000 feet up and it's moving away, the angular size of it would change. And then if that doesn't, if we can take it, I can do an example like this and I can have the same light somewhere and put sticks on it. And then I can measure the light and see if I can get the radius of this basketball.
Well, the problem with shadows on a curved surface is the shadows are going to be more elongated. They're not going to be. You can't actually measure the shadow specifically because they're elongated on a curved surface.
Yeah. And it might, well, yeah, it depends on
So
where the
that
light source is at though,
so
right? Because if the light,
that'll
like
distort it.
I can see it right now. There's hardly any shadow on my finger, but as I move the ball, the shadow gets longer. And it's not just one shadow I'm measuring, it's going to be two.
Yeah,
And
no,
I'll do
but
it on the same line.
it's still going to be elongated. It's still going to be distorted, elongated because of the curve.
Yeah, but that's the point. That's what I mean. Like, that's the.
Yeah, but shadows on the ground like Aristophanes did, they didn't curve. They were just there, right?
No, you're right. They didn't curve, but one of them was different.
Yeah, but
One of
the
them.
shadow itself was still even if you take the well thing, as the Aristophanes, if you take the well part of the story and say that's the story, the light was just coming down into the well, right? And then it was,
Yeah, so the well one, it says it lights up the whole bottom. He sees the whole bottom perfectly.
at the one spot, and then only part of the one, but that's all the same on a flat earth or a flat surface with a local
Take
light
these
source.
on here. Yes, yes. You're right. 100%.
Yeah, so we could say
And that's why we measure the distance.
yeah,
So
but we could
because
say
in order
the
to do that,
shadows could work on both, except for the elongation of the shadows. And that's the thing that they don't say in any of the Aristophanes experiments. If
I
you
don't know what you mean by elongation, though.
so this is what you do. What do you got in your hand? A marker?
Yeah, and that's what I was
Yeah.
trying to do here on my ball.
Right.
But I
Yeah,
need to get
so
a single light. I need to get
just
it.
take a flashlight. You'd have to make it more controlled, where you're not holding it. But you can kind of see it. If you take a flashlight or your phone light or whatever, if you take your phone,
I have a light.
Yeah, it's gonna have to be a little bit more controlled, but you might be able to see it. If you measure the distance between the shadow and the shadow, if you have the light at the same spot as you do on the table as you do on the ball, the distance from the pin or the marker, and then you measure your shadow distance on the ball, it'll be longer than it would be on a flat surface.
To tape them too. But right here, my red one, I don't know if you can see, is almost casting no shadow except for my fingers casting a shadow.
Right.
But the blue one is casting a longer shadow. So now
No.
I would measure the distance between the two, measure the actual height of them, and then I can measure the shadow that the blue one's.
Yeah, no, I know that.
To get the angle.
What I'm saying is, as a control, right? You measure the
Do it
shadow
on a flat surface.
Yeah, so you measure the shadow on a flat surface. The distance to the pen has to be the same, though. You can't change the distance.
Yeah, no, I would have to absolutely.
And so
that's a good control. You're 100% right. I think you should do the same thing with measuring the temperature of the moon. You need to control beforehand as well.
Let's say my name tag here was the table, right?
Mm-hmm.
You know where my name is, and then if I put my globe, at the same height as the table, right on the top of the surface, so if my if my phone is a table, you have that at the same height, and then you put the marker or something on there. Measure how long a shadow would be on the ball or on a flat surface. Your shadow on the ball is going to be elongated because it's curving down. So it might not be much,
but
it's
the
gonna be,
light, but let's see here. It's nighttime over here. And we got a whole line on that ball, just like the moon, like the phases of the moon right here. Like
yeah. So did you hear anything about January 8th or
no,
June 8th? June 8th.
June 8th.
So, and you have to look at it from okay, June 8th was when 99% of the population was.
Oh, it was in so yeah, absolutely. Yes. Okay, I didn't know what you meant by that. Yeah, no, it was 98.
Yeah, that
no,
doesn't work on a
90%.
ball. It doesn't work on a ball. No.
Oh yeah, it does.
No, it's been shown over and over again that it can't.
Well, okay, maybe if you agree with that, they're lying about the numbers of the population, which.
No. We take the population, right? And then you could even take timeanddate.com, which is just a tool, and map that out on a globe, and it can't work where they say the light was.
It's yeah, I'll look into that because I remember the whole thing happening because I was kind of big into this. I dropped this whole situation for a while.
Yeah.
I talked a little bit about it earlier. I'm in recovery. And then so I find myself getting not obsessive, I guess, but I do. One of the things I am obsessed about is learning the truth about how reality works.
Yeah. So that June 8th thing, where 99% of population, but you have to get away from.
I looked at it on a ball of how it worked, though. It does work. On that globe you're holding, the amount of people that live, it was like all of Eastern United States, all of Europe, all of Asia. I believe a bit of Australia was in it too, which is kind of doesn't matter because it wasn't Australia because it was summertime, so it was tilted the other way. Most of the population is above the southern hemisphere, and then you have the big old Pacific Ocean where nobody.
You have to forget the number.
The northern hemisphere.
We're not talking about the number of people. That was just how they worded it. You have to look at the physical light, where the light is actually at, not the population. Nobody cares about the number of the population.
That's what they said, though. Yes, it was the population that has.
No, I know.
Light.
But if you take, what I'm saying is, if you take the timeanddate.com and you match it up and then try to replicate it on a globe, it doesn't work. You can't get, and then they say, and then because it needs to be like 70% or something of the globe lit up in order to make it work.
Well, that's not possible because that doesn't work.
Well, right. I know that.
I will agree with that 100%. That the globe is only lit up 50% at a time.
50% of the surface can be lit up, right? So if they say 99% of the population can be lit up, then you have to take in consideration where all that 99% of the population is. So, have you ever seen an image of the Pacific Ocean from space?
Probably.
So I'll pull it up real quick. Okay, so this would be, I don't get why they. Okay, here we go. I'll add this. Okay, so where did my thing go? I had it pulled up bigger. Okay, anyway, this is what they say the Pacific Ocean is like from space, right?
Wait. Earth viewed 15 degrees. Okay, yeah. And see, that's what also confuses me sometimes because sometimes I'm not gonna lie, the pictures do look fake, but I also have to recognize that I don't know what it looks like.
I want to make me a point with this here. I hate how this is. Like,
but so far it's not going
the new
good
Windows
because
stuff. I hate how the new Windows stuff is all all messed up. I can't even get the computer to do what I want it to. All right.
See, this
So
isn't
this
a
here,
good.
no, I'm
This
just
isn't
saying,
that.
right?
I know, but it's not looking good for your theory because if that's half, we're looking roughly half.
No, this is just what they say. That I'm not saying this is true. I'm just saying this is what they say the Pacific Ocean is.
Okay, so
This,
based on if we're saying this is what they say, then that means about
right.
most
So
probably not
you
many
could,
people live in this little section.
right, you could say you. I'm saying this is how you could try to justify this, but it doesn't work with the time and date thing. This doesn't work with time and date. I'm trying to give a globe justification. Is what I'm trying to do.
Yeah, yeah, yeah.
I'm
Yeah.
trying to
All right, and I'm
lean
all
toward the
right.
globe. Okay, they say this is this would be a 50% view of the Earth because you can't see the other side, right?
Yes,
Now, now, and they say that's just the Pacific Ocean, right? Just the
matches up
Pacific
on the
Ocean
globe.
or whatever. But time and date. So then you could say okay, 99% of the people live on the other half of the globe, right? You could say that from this
Yeah,
image.
is that the actual number? The 99% population? I knew it was in the
Yeah, they
90s, but I
said
don't know if it was
99%.
99%. Okay.
But what I'm saying is you could say that. You could say, okay, so 99% of the population lives on the other side of this image, right?
Hmm.
Yeah, so but that doesn't work with the time and date
And
thing.
the majority are in the north, which if it was June around the summer solstice, that's when it's getting its maximum tilt on the northern hemisphere.
Yeah, but that should happen longer. But anyway, you have
Should happen more.
timeanddate.com and you
Hmm.
can see where the light was, where the sun and moon are and stuff, because that's
Yeah, and
where
you
people
even if
track
you go
it.
to that date, you can record. You can without looking at it visually, you can say, okay, this is sunrise in
Right. So
California.
what
This was sunset
so
in
what
England.
you do then is try to replicate on a toy globe, right? How you can light up the area that they say is lit up on that date, and it doesn't work.
Well, show me. You got a globe,
Yeah, so it would be hard to see because uh, they had
and because I
they had
remember it was.
California just lit up, barely lit up, right? And then it was all the way to
I thought they excluded California completely, but I guess I could
no,
be
it
wrong.
was there. It was like, and then it was all the way, and I had to turn the globe to do it on here just
Yeah,
so you
well,
can even
because
see it. But it was even all the way to Australia, right? So from all the way from California, and I'm turning the globe to get there, right?
you also have to tilt it though a little bit
Well, I can tilt it or whatever, it doesn't matter. But all the way to Australia around here, that was time and date. And if you shine
because
a light, if you
I'm
try
gonna
to
get a
get a
globe.
light to do that, it has to be like 70% covered. The Earth is, and it can't be over 50%. It can't be over 50%. You can't do it over
Yeah,
50%. But
and I guess I'll look farther into it of what they mean by daylight because obviously, even on the flat Earth, we're distinguishing sunlight between daylight. So as the sun's setting, the light still may be shining through, just like it's dusk or even dawn, and they can be counting
yeah,
that as sunrise and sun.
but the light from the sun can't light up more than 50% of the Earth.
And then if you agree with that, then that means there can't be a 24-hour sun in Antarctica. Because if you're willing to say that the dome and coffee cup coffee can light up some of it, maybe it can light up 99% of it. And the reason why that it is doing that is because there is a firmament there.
Right.
That's a possibility because it's doing something weird.
Yeah.
They're trying
Right.
to say it's so. I mean, and I'm not just. This is very possible because I'm gonna look into this. So maybe that is why we are getting light because some freakish phenomenon was happening because they all know it's not a globe, and we were getting some weird refraction thing going on with whatever surrounding us. I'm not necessarily disputing it. My only problem with that is physically I can see meteors and there have hit near my town where I've lived. One just hit Texas not too long ago. It was huge.
Well, yeah, yeah, I know. We had a conversation about meteors, and again, I'll say they're. What I would
They're
say
from
is
somewhere, but you're not
they're from
proposing a
some military
logical.
base.
But that's not logical. That's a fallacy. You can't. And
But the government has been known to blow up stuff, through
absolutely,
tall
and
buildings.
I do not deny it. Hell, they've used sonic booms to just destroy houses before. They blew up West Philadelphia. I mean, that wasn't necessarily the government, but they completely blew up West Philadelphia back in like the 70s or 80s. I forget when it was. And maybe it was
Uh,
the early 90s. I don't know, but no, you're right.
but
You're right.
and we could say that's all speculation. So let's get out of the speculation and get into the.
But well, no,
And
what's not
I'll
speculation
always
is the thing falling down.
something.
That's
Yeah,
not
something came down and hit. Yeah, absolutely. Something came down and hit the Philadelphia or
hit
whatever.
houses.
Right?
It's
Yeah,
yes, and then now we get into other sciences where these things are collected and then studied and measured and learned
Hey,
about
what is your thought on what happened in Hawaii?
what happened in Hawaii.
Yeah,
Oh, the blue.
Hawaii?
Oh God. I don't know. I don't even know the fire, the blue beam laser. I didn't even follow that. Next thing you know, they're talking about Oprah Winfrey and The Rock talking about selling kids online. That's just a rabbit hole that now, because I was like, okay, shit, maybe it's going on. But then I got to step out of myself and say, wait, now I'm just fucking grabbing shit and mashing it together and hoping it sticks. And that's not a logical way of thinking.
Or it's all or what people say is all true, and you should paint your house blue.
Could be. Could be, and I did not want to bring kids into this world,
mean-
but unfortunately, they're here. But it's, oh God. I mean, P. Diddy, all this stuff going on.
Oh yeah,
And I love that kind of stuff. And I am a firm believer that the human psyche is capable of very terrible, terrible things. And a lot of it was done in the name of God way back when.
oh yeah, some
And
crazy stuff.
some people think that, I don't know, I guess if there is no God, there is just science, because the church would burn people like that would talk about science and
Well,
proving these things. And,
yeah,
you
what
know,
church are you talking about?
the Catholic Church.
Yeah, right. Okay.
And they would, you know, I don't know. Now a
Yeah.
lot of them
No,
are more
I
accepting
agree
of
with
it.
that. I agree with that. Okay, so let's look at this video here. I think minus the minus like the mockery sense of it, because there's some of that goes on.
Yeah, and that's what I kind of don't like about Dave's videos too. You know, whatever. Say what you will, maybe he fails classes. I don't know. He
Oh yeah.
seems to be
Oh yeah.
intelligent, and I'll also
I was
say
gonna send you
Austin
those.
seems to be very intelligent. That Austin seems extremely intelligent.
Right.
But I'm not denying Dave that you can't just say, "Oh, it's electrostatics," and then not really prove it, and you're just saying things at a certain point. Like,
Yeah.
kind of like with what we were talking about with math and the numbers. It might sound like people are just saying them, but they actually have meaning. They actually do stuff, and it's because
Right.
of numbers like that.
Right. And my point was just to an extent, right? So, like I
Yeah.
said, I can math my bank account, but it doesn't matter if I don't have that money. You know, that's not reality. Reality
Yeah,
is
and
that
that's not
me and you could
actual
go to the bank and withdraw some money. That would be reality.
100%, and that would be amazing. And or measuring distance, that's reality.
Right.
All right, what
Okay.
we
So
got?
here's this video here. Let me see if I
Impossible
can.
Day on the Globe, the Weather Channel.
Let me know if you can hear it.
July the 8th was a very interesting day. It was the day that even the Weather Channel proclaimed to be an impossible day on the globe. I only found one video, and that was also made by the Weather Channel, trying to
7:15
demonstrate
a.m.
this event on the globe. And as we can see here, the light of the sun clearly covers 60 to 70% of the globe. So we have 60 to 70% of the globe wrapped in sunlight. That's impossible on the heliocentric
Wait. Keep
model.
spinning, though. Keep spinning.
Sunlight cannot cover more than 50%.
What was that?
I just want him to keep spinning, that's all. He's not
Oh,
spinning.
of
I
the
would like to
globe.
see the dark
But
side as
as
well.
you see on this simulation by the Weather Channel, to be possible for the sunlight
like the
to
moon
cover
right there.
all those regions on Earth, it's necessary that the sunlight covers between 60 to 70% of the globe. Not being able to show, many news channels are showing the Mercator's projection because that's the only one they can show.
One more thing this half hour. There is a rare phenomenon happening right now across the globe.
I remember
As
this.
of about 3 minutes ago, 7:15 Eastern time, 99% of the entire world's population is facing the sun.
And
That means
California is cut off.
we're
by the
all
way.
experiencing some
That's what
degree
I
of
thought.
sunlight at the exact same time, either full daylight or for a lot of other folks, twilight. If you look at the map right there, just the Pacific
Southern
Islands and
America.
Australia, the Australian region, are fully in the dark. 99% of the world.
And
Oh, so all of
California. Poor
Australia.
California.
Yes.
You know what, though? What a cool phenomenon.
This
So,
poor
okay.
guy, he tried to demonstrate on
Screen shooting this. You're good. I just wanted to take a screenshot of that. Because I want to measure that on the globe. And I want to take those spots. Oh, they even got the moon on here.
Yeah.
And they got noon. They got noon right here in
Somewhere in Africa.
what is that?
Libya or
Lebanon? No,
Yeah.
yeah, Libya. Okay. All right. No. Because and even up in Alaska. Now, do you remember what time it was on that day when you were up there? Can you at least corroborate that there was sunlight at that time? I don't know. Maybe you have a photo on your phone with the
Oh,
date.
in
stamped
July
on
we
it.
have sunlight. We have sunlight 24 hours a day in July.
Oh yeah, that's right. Duh. Okay.
Yeah. So
Well,
it's
this
like
was June. Right?
we have
Oh, this
so
was,
in
July the
Alaska,
8th. Oh, okay.
we get 72 days where the sun doesn't set. Now it does go below the mountain.
But you're
horizon.
still seeing a significant amount of light. It's almost like a
Yeah.
dusk or a dawn, right?
No, it's the sun.
Oh, okay.
Yeah.
But okay, so
let me keep playing this here.
yeah, go for it.
the globe how that could be possible, but he failed miserably. So he had to go to his computer and demonstrate on the Mercator's projection.
On July 8th of every year at 11.
So this guy, right, is trying to
Oh, and
show
it's every year?
Yeah. He's a glober. This guy with his gay bow tie.
Oh, that's at homes or
That was
whatever.
harsh.
Hell.
Okay, anyway, that was an opinion.
I guess,
this
yeah.
This guy's a glober, and he's trying to prove how it can be done on the globe. He's a glober, okay?
Yeah.
15 Universal Time. That translates to about 7:15 Eastern Time. 99% of the world's population, just over 99% of the world's population, is actually in sunlight.
2 hours later.
The reason is actually kind of interesting once we kind of delve into this a bit.
7 hours later.
So, I mean, if you look at the Pacific Ocean, this just kind of gives you a rough idea. Imagine if the sun was lighting up this section of the Earth. You see that there'd be a very small amount of Earth's population. Right. But over here, when you get Asia, Africa, maybe some of North America and some South America, you can see that you have a much larger percentage of the Earth's population that could be in sunlight.
1 eternity later.
Let me reference this tweet. It's actually kind of cool. And if we take a look, they actually put a map with it that helps explain this just a little bit. So if I zoom in just a tad, what you can see is that
I think he's
July
doing
8th
this is
at
because it's
11:15
hard to
UTC.
see on the globe.
No, so you couldn't do it. I don't
know if that's what he's necessarily trying to do. He was he put those cut scenes in there about how long it was. We don't know if that's really how long it was between each thing. I didn't really see him go, oh, okay. Oh, wait a minute. Hold on. No, I just kind of heard him saying, look, people live here in Africa, people live here in Asia,
Yeah,
people
so,
live here in the United States.
course-
And then those cuts were added.
The video is cut and they put those 1 hour, 7 hours, and they turn it to later, which is funny. That's why I was talking
Yeah.
about the mockery.
No, the mockery,
it's funny,
but we
but
don't
still.
know if he really waited that
But
long.
you can
if
go
he
back.
was
You can go
struggling.
back and watch his video.
That's what I'm
guy-
gonna do.
Time. That's Greenwich Mean Time, if you're kind of curious, right through Greenwich, England.
So it is impossible for the sunlight to wrap around the globe between 60 to 70%. So there is no other day like July 8th to
I don't think that's
demonstrate
60,
how
70%
wrong
though.
the heliocentric model is. And to better understand, all we have to do is to convert the Mercator projection into the flat Earth map and see how it makes more sense on the flat Earth map. With a small sun, a small local sun, you can see here how it illuminates those regions on Earth, leaving the majority of Earth in the dark. Only on the flat Earth model, even this map by Weather Channel, I converted into a flat Earth map, and you can see here it's better explained with a small and local sun circulating over the flat Earth we can see how this is possible for a day like July the 8th. If you still believe in the heliocentric model, yesterday was the day for you to drop that model and realize we don't live on a spinning ball spinning around the universe. The Earth is flat.
So right there, about right there, maybe back a couple seconds, would be where 99%
Yeah, it would
of
be
the
it. Yeah.
right, and that he's showing that on
The moon,
of
I don't
course,
think the moon is matching up though. Where the moon is on the flat Earth, the moon's not matching up with reality.
no, he
'Cause
showed
the
he showed
moon's-
it earlier.
I know,
don't
but
know
I'm saying
why-
the moon. No, they were showing on the news where the moon was at. That's why I pointed it out, and it was over Libya, the
Yeah.
sun. But the
But he
moon on his
just
flat
con-
Earth is not, and it's
But he just
always seems to be
converted
doing
that.
that.
He just converted that to the he converted what they use to this, and I don't know how they do that. So I don't know how. I'm not technically advanced to do this conversion from one map to another. I don't know how they do that, but he did it somehow. So if we were to go back a little bit, he says he converted it.
And the Mercator projection, those are all out of whack.
Right there.
I believe the northern and
So-
southern is all stretched out because you can't make a globe flat. You can't
Right.
take
So this
the
here,
area.
right? This moon here was where it was accurate, but the moon is still moving and stuff too.
Yes, but
Right, so-
in
but
all the
anyway-
other ones, it's always deadly right across.
Yeah,
not
so
in
you
any
can
kind of
you can
daylight.
you can get into that yourself. Like don't take this guy's word for it.
100%.
Try to
I'm
try
not.
to. But the thing is that they use the Mercator map to show just for time and date, right? So,
Yes,
but
because
you
it
could
properly
validate
reflects,
you know,
and that is where the sun
where people
goes.
can
That's
see
how they
light.
show orbits
Yeah,
on the
people can
Mercator
have
map
daylight.
too. It looks crazy.
Yeah, it is crazy, but the time
Just
and
because
date
something
is
looks crazy though doesn't mean it's not true.
the what?
Just because something looks crazy though doesn't mean it's not true. Right? I mean, we
Oh,
can
right.
both agree on that. That just because something
Yeah.
looks kind of crazy, whoa, out there, doesn't mean it's not true.
But to replicate it on a globe is the
I'm gonna
issue.
buy one. I'm gonna order one on Amazon, and I'm gonna check this out myself. I need one anyway if I really want to start kind of messing with a couple things.
Yeah.
But yeah, I forgot all about that because I remember thinking the same thing. I was like, "That's crazy. That don't make no sense." But then, of course, I take into account that Australia wasn't lit up, and even though California was on there, I'm pretty sure it was like a sunset at that time.
Well, they said
Sunrise. No, it was
California in the
sunrise.
dark anyway. It's like a pun.
They, yeah,
It's like, oh, they're in the
but
dark
it's just
anyway.
the way they had the. Yeah, no. The way they had their lights, one was really faded. You had the big sunlight, and then when you got towards the edges, it was like medium, and then one was like barely. Then it was dark, like
But
twilight.
so
I
like
don't know. I don't know if they're counting
just-
that as daylight.
right, just to demonstrate, like you have a flat Earth map model type of thing, and a
I wish I could put it on
Earth
this.
model type of thing. It can be demonstrated with a animation, but it can't be physically demonstrated with a globe of 60 or 70% of the globe in daylight. That's just something to look into too.
I'm not gonna. Damn it! I'm not gonna be able to do this properly. Not at all. I'm trying to see. No, yeah, I didn't do that properly. I'd have to hold it there. I want to mark the edges of where the darkness starts on my little basketball. I'll just get a globe. It's obviously not very scientific, but
Yeah.
I need one anyway. So I guess because I gotta get showered and get ready for bed here in a
I gotta
minute.
get-
But
yeah,
my final thing would be if we can agree to try and measure the distance of the sun. If we can assume it's flat, we can measure the distance. We would have to then come up. Now I'm saying we do this ourselves if you're not willing to take that other video into account, but we would have to come up for a reason why the sun's angular side doesn't change when it moves away. If we agree
Oh.
that it's
I can
6,000 miles
I can
up.
try to give a small explanation of that besides atmospheric magnification. Besides that, so the sun will always be in the background, right? Like it'll never be in front of the physically in front of a mountain. It'll never be in front of the. It'll always be in the background because it's always beyond that, right?
As well as a cloud.
Well,
Hey,
the sun is-
I'm fine with agreeing with this, but as long as we say as well as a cloud.
the clouds. It's beyond the cloud too, right? The
Okay,
sun can
yes.
be
All right,
beyond the
good.
cloud.
I
Okay.
just want to
So-
I just want to smash that right there.
so
There's no clouds surrounding the sun.
From my from where I'm standing, you have stuff that's right in front of you, and then you have like a car or whatever. And then you have
Yep.
like a building, and then you have whatever mountain out there in the distance, right? And
Yep.
so, but the mountain out there is going to stay the same size, even though your vanishing point is going to be before the mountain. You get that?
Kind of.
So like your vanishing point of what you can see is only it's based off of your height, right? So if you're 6 feet, you can only see so far because the ground and the sky come together, yeah?
Yeah.
Or it doesn't matter if you're on a ball or a flat earth.
No, yeah, it all
The
converges.
sky and the ground is going to come together. It's going to come to your viewpoint, right? Now,
But we
that
can still see the
viewpoint is gonna
mountain
be-
back there.
Right, it's going to be condensed, but then there's a mountain back there, right? So the mountain's still gonna be there, and it's still gonna be its size. But my angle of resolution has come to a condensed before it gets to the mountain. Okay,
Yep.
Now, if
Like
I
a
go up, my
car
angle of
driving towards the
resolution is higher.
mountain and it's disappearing.
Right, so the mountain can stay there while other stuff disappears in the foreground. Right.
Okay.
Right. So this is something you could do. Take like 2 golf balls or tennis balls or whatever, right? And put a tape measure on the floor and measure. They're the same size golf balls, right? And if you come down to one side of the golf ball and you look at the other one's going to look smaller, right?
Yeah, because of how yes.
Because
The angle
further away.
size of it changes.
But if you come up above the golf balls or the tennis balls, and you look at them both from like the middle at 6 feet high, so you got an isosceles triangle, right?
Yeah. And I'm looking at one and they're both the same size.
Right. So they're the same size, right?
Yeah.
So being that the sun is always in the background, it's not going to change its angular resolution because it's already in the background.
But it's not always in the background if it's sometimes overhead and we
No,
get
it's always going to be.
and I'm not assuming it's a globe, okay? So I'm gonna assume that it is going
It's always going to
overhead.
be the same. Like when you're looking at it, your angular size doesn't reduce because it's already reduced. It's already reduced to its minimal or maximal angular size because it's already whatever distance away from you. But when you're seeing it, it's just in another position, roughly the same distance away. So it's going to be hard to detect the angular size.
But
And
that
it's-
also
and
no,
it's
because
always
then
in
if
the
it's
background.
I know, but if we're saying that 12 noon and the sun is directly overhead, I have to look up 90 degrees. There are no shadows being cast on something standing up on it because it's 90 degrees. It's straight. The shortest distance to an object is a straight path. So when it then goes farther away, if it is truly local and it is the thing that is moving, well, why, despite being in the background or not, why isn't it getting smaller? And then also, mind you, we could do this over the ocean and there would be no background. But it still stays the
No,
same
the
angular
background,
size. Solar filter.
The foreground and background is just where you can prospectively see to, and something
No,
that's in
absolutely.
the background. Something that's in the background won't change your size because it's not changing. Like the mountain's not changing any further distance from you, right? Now, if you go
the mountain's
further,
staying the same. If I go further,
if
the
you
mountains
go
will shrink.
further, right? Yeah, so it's going to stay the same size, but your angle of resolution is going to come to a point maybe before it gets to that mountain. So you can have a perspective get all to one point, vanishing point, and still have something larger in the background.
Yeah,
That doesn't change in size. So being that the sun is always in the background, it's not going to necessarily change the size.
Because
of
it would
the
change in
angular
size.
resolution.
Because if you go to the Himalayas and then you see a mountain in the background, but in the background of that mountain is also another mountain, and then you might even have a higher mountain in the background. You see peaks, and they all get smaller as you go farther and farther away. but the sun doesn't.
Right, because it's at a further distance already at its. And I'm just saying this. I haven't done anything to prove this. This is just a thought that.
Yeah, so that's why I want to. That's why, if it's already at its further distance when I'm looking at the sun back there, and I measure the circumference of it of what I can see, like you could do with the moon. The moon is always the same size. I can cover it with my thumb, no matter where it's at in the sky. It's never
Oh no,
bigger. I never have
there's
to
been
move.
times where the moon is, and I've seen this. I've tried to take pictures
And it's
of it,
bigger,
but
yeah. But if you look at it
it's
under,
huge.
if you, I forget what it is, you flip your head upside down, or you try to take a picture of it, it's just normal. That is the difference of what's in the background and perspective, making it look bigger. But I think if you stand upside down and you look between your legs, it'll look normal. And it's crazy because I tried it because I thought the same thing. Like, holy crap, the moon looked crazy tonight.
Yeah,
But it is just
that's an argument Dave Weiss uses. That's funny that you said that.
what
To do that.
to look between your legs.
Yeah, to do that
Well,
experiment.
no, because
yeah.
it changes your a whole perspective of it, and it
Yeah, right.
goes
Yeah,
back to a normal moon.
Dave Weiss uses that. He tells people to do that. It's funny.
And it doesn't
Does it-
work. Is that what he's saying?
No, it works. Yeah.
Yeah, because you're looking at something that you think is big and it looks all crazy, but
Yeah.
you go and you look between your legs and
Right.
it's small now.
Or whatever. Yeah. Right. So
Unless he's saying it
But
doesn't
yeah, I mean,
work. That,
those are just different things, that you can kind of go into, like the June 8th thing and different things like that. I'd like to do a video with you next time.
right.
It's going to be, in 5 days, 6 days, next
that's
Wednesday. Or
fine.
something.
We can talk and maybe have a plan.
Sure.
Like I'll probably be at
Yeah.
work.
So I got some things that I would like you to just be open-minded about to see, right?
And I am
And I wanna
and
go-
I'm trying my best.
And I want to go through it with you. So
All right.
just to see what you think on it.
100%.
But yeah, I gotta get off here. We're about to
Yep.
have dinner.
I'm gonna
so-
shower and get ready for bed and stuff. So you have a good night.
Yeah,
nice
you too.
talking to you.
You
Have
too,
a good
brother.
one. Later.
All right, that was pretty good. That was interesting there. Where you go? Still. Yeah, so there's a lot of conversations and there's a lot to talk about. We get through some things, but Michael wants to do a test of shadows, and we could do that. And that the group Firmament Tracker, they show different people across the world, can see the moon at the same time when you shouldn't be able to, and it's on the opposite side should be on the opposite side of the globe, Earth or whatever. And I'm part of that group. And we get together online and say, hey, can you see Orion's belt right now? Whatever. Now I'm limited on that in Alaska because we don't get sunlight during the summer, or we don't get dark during the summer. So I don't get to go outside and watch the constellations or anything like that because we don't see them. So and there's times when you can see the sun and the moon and the sky at the same time up here in Alaska, which is kind of weird, but it's interesting. All right, so yeah, just stay tuned. If anybody's watching, send me a comment or something. All right, bye.